Hey, what's up guys, my name is Cherno and I am excited. It's been about a year since we had that first glance at Unreal Engine 5 and here we are with 15 minutes of Unreal Engine 5 early access, and in fact the source code for this is now available. This new technology that we've seen has been exciting for a number of different industries for a number of different reasons. For me as a game engine developer, this has been something that I've been looking forward to seeing ever since we saw that first look. And to be honest, it's been out for like, what time is it? It's been out for like 15 hours at this point. So I still haven't seen any of this because I've just been waiting to finally get the chance to sit down and record this video. So for those of you who have no idea what's going on, Unreal Engine is a game engine that I'm sure a lot of people subscribed to my channel have heard of. They've been working on Unreal Engine 5, which is the next kind of big release of their technology. And early access is finally here and available to try out. And this is a video explaining what that is. If you're new to this channel, then welcome. I am a game engine developer. I used to work at EA on various game engines, and then I quit to start working on my own game engine, which is called Hazel, and that is what I'm currently doing, as well as making educational YouTube videos on the topic of programming and game engine development. I'll have some interesting videos linked down there if you want more information. But anyway, without further ado, honestly, let's just dive in and take a look at this video, because I'm beyond excited.
Hi, I'm Chance Ivy, Senior Technical Designer at Epic Games.
And I'm Galen Davis, producer and evangelist for QUIXEL at Epic Games.
This is reminding me of the first video.
We revealed the first look at what's coming in Unreal Engine 5, the next generation of our real-time technology, and our demo, Lumen in the Land of NANITE.
Okay, so Lumen was the basically the global illumination technology that they had. Lumen, you know, lights, that makes sense. And then NANITE was, I believe, the mesh kind of decimation, whatever they had to reduce the massive amount of polygons that they had kind of in their source assets. So like all of the incredibly detailed meshes that they had, how they would be able to reduce that complexity so that we could actually render it on screen in real time.
Since then, the engine team has been working hard on preparing the tools and technology for creators around the world to get their hands on so that they can explore the new features and provide us with feedback.
Now, just a few months ago, we assembled a small team of developers to see what they could build using these new features. The result is a new practical sample project called Valley of the Ancient. And today, we're excited to give you the very first hands-on look at some of the new tools and workflows that we used to build it.
Now, we've got a lot to get to, so let's get started.
Xbox Series X. Cool.
When setting out to make our demo, we wanted to push the boundaries of what's possible.
Oh, those shadows are looking so noisy around the edges. Look at that. That is interesting. Anyway, sorry. I'm just pointing out what I'm seeing, and that caught my eye immediately.
We wanted to push the boundaries of what's possible with UE5 today, while targeting next-gen.
The amount of detail though. This is just like QUIXEL Megascans assets piled on top of this. So much detail. I love it.
Here are sequences running in real time on PlayStation 5 and Xbox Series X.
Okay, PlayStation 5 as well. I like that kind of turbulent displacement around the fire.
Okay, welcome to the brand new UI in Unreal Engine 5.
Ooh. Ooh, that UI looks nice.
While
Clean.
a lot of the same features and functionality that you've come to know in UE4 are still present in the new UI, we've added several new systems that put you at the center of the experience. For example, the content browser can now be accessed like a drawer using hotkeys, allowing you to keep a clean workspace while still having access to all the content that you need. We can also collapse and restore editor tabs to and from the sidebar, maximizing the viewport experience. And you're going to see a lot more of the UI as we get further into this presentation.
That's, by the way, one thing that I've kind of felt with Unreal Engine 4 was that like there was just so much going on in the UI and I just wanted to focus on my viewport and it was just kind of difficult. So this is nice. I like that this is here.
We can't wait for you to get your hands on it.
That's actually one of the things that I really want to do with Hazel as well, is make sure that you can kind of easily snap to a view, kind of like tab in Photoshop. I don't know why I'm comparing to that, but that's something that I've been using lately. Just hitting tab to hide all of the tool panels immediately so you can actually focus on kind of what you're actually working on rather than all the various tools. Because if you know the hotkeys, and if you've already got all the meshes in your scene and maybe you just want to fly around and see how it looks, you don't need any of those tools nearby, you know?
One of the main features of Unreal Engine 5 is NANITE, our virtualized micropolygon geometry system that frees artists to create as much geometric detail as the eye can see. Virtualized geometry supports orders of magnitude more triangles without compromising speed.
This I'm super interested in.
Traditional system of mesh LODs, handling all detail transitions seamlessly without any additional setup.
One thing I want to quickly point out is that, like, the closer we get to a world in which artists can forget about technical limitations, I think the further and the better games are going to start becoming, right? Because for anyone working offline, in offline rendering, or even more offline, like literally with physical media, like a painting, it becomes so clear how specific game development is and how it's so kind of different than all of those other art disciplines. Don't get me wrong, if you're offline rendering like some kind of feature film and you don't need to process anything in real time, you still very much care about performance. You don't want frames to take days when they could take hours. That's a big difference for a project. However, what I'm more talking about is, when someone sits down to do a painting, they don't worry about the detail level of stuff in the background, like the mountains. I can't put that many flowers there, or I have to make sure that when the camera is far from those flowers, they're still kind of there. They don't rudely pop in, but I can't have too many of them because then like the performance is going to suffer, especially on like that kind of lower tier hardware. And then like, but I want it to look good from a distance. What do I do, and how do I gradually blend that kind of transition into being closer to it, because now I want more detail? All of these problems are so specific to real-time kind of interactive application rendering, like what games are essentially. And these new tools that are enabling us, well, supposedly I have not heard that much about this, but based on what they're saying, no LODs, no level of detail systems, meaning we have basically multiple copies of a mesh or other asset, I guess. Well, I mean, for textures, it's called like a MIP chain. But in the case of meshes, having multiple copies of it that we can kind of, transition between as we get closer, then we have to worry about that because we can't afford that kind of level of detail further away from the camera. Having to not worry about that, and for artists to just be able to create the content as if it was a painting and then everything just works, that's amazing for the future, honestly.
In other words, NANITE lets the artist create while the engine does the work.
Yeah, exactly.
Switching to this
That's
NANITE visualization,
the dream.
you can see individual triangles rendered out as different colors here in the viewport. And because the geometry is now virtualized, you can feel free to place assets like these all throughout your scene to fill out.
Yeah, that's incredible. Like, me looking at all this stuff in the background, just being there, and the fact that, like, if we go back to that triangle visualization, those are literally like triangles there. They're not like some kind of thing that's painted in or like a texture or whatever. They're literally geometry, right? Each one of these little colors, I imagine, represents a completely unique triangle. And a lot of them over there really are like 1 or 2 pixels big. And the fact that like their NANITE system is able to kind of work out the fact that this triangle contributes to this pixel, supposedly, I'm not sure how it does that, but that's incredible.
Geometry is now virtualized.
Like, this is the real deal.
Feel free to place assets like these all throughout your scene to fill out a massive player space. Using this debug view, you can see individual instances represented by different colors from swatch to swatch.
Okay.
Each instance in this environment contains around 1 to 2 million triangles, providing enough detail for the camera to roam with complete creative freedom.
I'm not sure what they mean like by instance specifically, if they mean like a separate kind of mesh or a sub-mesh, or if they're talking about like a material kind of group, like a primitive or something. I'm not 100% sure.
Now,
they do look like meshes
new
there.
Anti-aliasing solution, temporal super resolution, keeps up with all this new geometric detail to create sharper, more stable images than before.
Yeah, just looking at this, like the anti-aliasing seems, I mean, it seems perfect. I can't really fault it, to be honest. This looks great. I haven't really heard of like temporal super resolution, so I guess it's some kind of super sampling that they're reducing.
Resolution keeps up with all this
and
new
it's temporal, so I
detail
assume it's
to
like
create
frame to
sharper,
frame.
more stable images than before, with quality approaching true native 4K at the cost of 1080p. While highly detailed assets are great on their own, high quality lighting that realistically reacts to your scene is what opens the door to more dynamic worlds and immersive gameplay. Lumen is our fully dynamic real-time global illumination solution that immediately reacts to scene and light change, making for more believable experiences.
Those shadow edges again.
Settings, allowing for true physically based setups for photorealistic environments. The Megascans library has meticulously calibrated physically based surfaces and objects in the thousands of assets as of today, and the assets that we're highlighting.
That just reminds me of like Tatooine or something from like Attack of the Clones. I mean, this like, it looks like a movie, and that's incredible.
Show just how powerful it is to have.
And just to be clear, the reason why like it's sticking out to me right now, the lighting is good, don't get me wrong, but at this level, it's not even that important. It's just the detail. It's just the actual meshes, the actual geometry, and the fact that I know that based on what they've shown us, it's all real. It's all real geometry. It's all real, super detailed geometry. That is really exciting.
Nanite and Lumen working in tandem. Also, thanks to the new Sky Atmosphere system, it is incredibly simple to quickly simulate realistic time of day, carefully art direct volumetric clouds, and make modifications to things like atmospherics, sun position, and fog. And for this example, we wanted a fully dynamic scene. No light baking, and realistic interpolation between the different times of day.
Yep.
Of course, when in development, having access to high quality content that's easy to use helps you iterate quickly and saves lots of time that can
That's
be
why
better spent
QUIXEL comes
elsewhere on
in.
the project. With QUIXEL now being a part of the Epic Games family, we've made the full Megascans library free and open for all Unreal Engine users. Bridge, our online browser for Megascans assets, has historically functioned as a standalone application for quickly exporting assets in bulk directly into the engine, albeit separate from Unreal. Today, we're happy to announce that Bridge is now natively integrated directly into the engine UI.
Yeah,
Now
that's
you
a
can
good
simply
move.
drag and drop assets directly into your scene for a more intuitive and connected experience. And simply logging in with your Epic ID gives you immediate access to thousands of assets to use for free in your Unreal Engine projects. We are constantly looking to enhance the value of the Megascans library. And today we're excited to announce that we're adding a brand new asset type called Mega Assemblies. Mega Assemblies are the natural next step for us in removing even more barriers for artists in crafting their worlds. By combining existing assets from the Megascans library, our artists are pre-assembling elements that can be quickly accessed and leveraged to populate your scenes. Using the Moab set, let's add an assembly to our scene. And just like that, we were able to quickly change the composition of this area in our map. With UE5,
What is all
we
that, like
changed
a
the
rubble
composition of
falling?
this area in our map.
Wow.
With UE5, we are reimagining what collaboration looks like for teams and projects of all sizes. A common challenge when collaborating on large worlds is deciding how to structure map content so that everyone on the team can easily work without asset contention, while also avoiding painful merge conflicts.
Yeah, that's too real. I mean, having multiple people work on a single project is just incredibly difficult to manage, not just from like a kind of a management point of view, but if like the actual project files, right? Unless you end up splitting up the scene into chunks and having different artists work on different areas of the scene, which isn't really ideal. Working on the same scene file is a problem that like the industry has been trying to solve like forever. So any improvement in that space is like pretty much always appreciated.
Easily work without asset contention, while also avoiding painful merge conflicts. A new system called World Partition makes traditional world-building workflows obsolete by changing the way that we think about map files. Rather than requiring artists to build out map content as a series of streaming levels, World Partition allows teams to think of a single map as one large world that gets broken down automatically into many smaller, streamable cells on a grid. These cells can be selectively loaded or unloaded in the editor to save on edit time.
It's like
resources,
Minecraft.
allowing artists to only load up the sections of the map that they need. On top of that, changes to actors in a World Partition map
interesting.
are tracked at the actor level, not the map level. This one file per actor approach empowers different team members to work on different actors in the same map without having to worry about their changes getting clobbered in a merge or having to revert to get someone else's edits.
Wow,
Now, this approach means you could have artists
one file per actor. That's a lot of files. This is interesting because I was having a discussion with like some people in the Hazel team recently about exactly that, like about how maybe we should reduce the amount of files that we create because then that can be harder to manage with version control systems. But part of the appeal of not doing that, I think, and doing something like this is that you almost move that whole kind of I guess asset like committing and tracking kind of problem into like another system, to a stable system like Git or Perforce or something like that, that you can just kind of managing an external tool in a way that's obviously been proven to work for large-scale software projects, rather than, for example, having Unreal Engine have to manage all of the writing into like serializing into like certain files, certain large files that contain like all of the actors, because that's like your scene file. Maybe it contains all of the actors, or worlds, they're called in Unreal. All of the actors inside that world are in that kind of world file. And then, what if someone adds an actor? Then suddenly I have a merge conflict potentially, and I have to make sure that when I kind of pull that updated world file, I can merge all the actors together so I can still retain both actors. Having separate files is as simple as just, oh, there's another file on disk now. No one cares about that. Like, that just works. And that's kind of an interesting approach as well.
Now, this approach means you could have artists lighting, set dressing, and reworking the landscape simultaneously, all within the same virtual space.
Yep. That's very interesting. I might have to take down some notes.
Managing this much content at runtime typically requires a ton of thought about how to stream relevant content in and out to stay inside performance budgets.
Yep.
Fortunately, World Partition handles that as well. At runtime, only the cells in a user-defined radius from our player are loaded, and as we move, new cells are streamed in, while cells no longer needed are replaced by their lower resolution, hierarchical level of detail, or HLOD version. And since all projects have different requirements, the cell size and loading radius are fully configurable to match each project's content streaming needs. Another feature that comes along with World Partition is data layers. Data layers are a way to categorize map assets and collectively enable or disable them when you want to alter the state of the world. Working in data layers, a separate group of artists was able to assemble a mythical reimagination of the environment with more interactive elements for our demo.
That's interesting.
At runtime, we can swap between these two modes, streaming thousands of actors in and out, and enter into the dark world. Let's see this in action as we go back to Chant.
Thanks, Galen. Many runtime and interactive frameworks in Unreal Engine are getting significant updates in UE5. One thing we've added for animation is an experimental new full-body IK solver, which is designed to give you better results with less work. Here, you can see it in action.
So inverse kinematics just refers to being able to position like skeletal bones correctly, depending, of course, what your definition of correct is. But essentially, feet that move on the ground, should react to the ground itself. If we have a little hill on the ground, we want like the knees to be bent. And that's kind of what an inverse kinematics solver does. It figures out where to actually place bones, depending on like the surrounding obstacles, or well, it doesn't have to be specifically with like ground and walking and other things. It could be like different constraints that you place on the bones that specify that, my hand has to be here, so therefore what angle is my elbow bent at, and where is like the rest of my body, and all of those kind of things.
As the rig for our player character, Echo, corrects itself to adjust for variations on the ground below her.
Yeah, so that's all the terrain, all the rocks, stuff like that.
Around 10 times faster than before. To build and maintain more...
And that's actually also something that we saw, I think, in the previous kind of demo, I guess, the first look a year ago, was I think she was grabbing like walls and stuff that were around her. So that's also an example of this system.
We've also added a new framework called Game Feature Plugins that will allow you to build and ship game content in a more modular way. With Game Feature Plugins, numerous core gameplay features can be built in parallel with better encapsulation and finer content organization. Game Feature Plugins allow developers to add activation instructions to extend...
This new UI looks great.
Register new input actions for players, and interface with other frameworks such as animation. When we shifted into the Dark World, we also activated a new game feature to give Echo a brand new attack ability. All of the assets and logic needed for the ability, including new animations, input controls, blueprint code, VFX, and audio, are contained inside this plugin. And core game classes have no idea that these assets exist until we activate it. We've also added a feature called Animation Motion Warping, which allows you to manipulate root motion animations to adapt them to the world. Echo's vault animation was authored to the specific dimensions of this rubble. Leveraging motion warping, we were able to add notify states in the vault animation asset that can react to transform data passed in via blueprints. This allowed us to reuse the same animation to vault over other assets of different dimensions, like these pieces of debris, by sending information about their size into the motion warping system. Before triggering the vaulting animation, a blueprint script determines her rotation, how high up she jumps, how far she needs to move to get to the other side, and where her feet should land.
Yeah.
Motion warping then adapts the root motion of the vault animation to match this data. Also, for the Rift Interact animation,
I will point out it definitely does look a little bit unnatural. Like you can kind of see that slide up that's clearly more excessive, because I assume it's not going to go in and start modifying, like, you know, how much weight she's putting into that jump or anything. But I guess as like a quick fix, potentially, it would probably work pretty well.
we used motion warping to place Echo in the perfect position in order to ensure her hand would always touch the rift. So on the topic of animation, Unreal Engine 5 also includes our in-editor rigging tool, Control Rig. Meet the Ancient, a film-quality creature imagined and built by our friends at the Aaron Sims Creative Company. We partnered with Aaron Sims and his group of talented artists to concept the Dark World and to bring it to life through an enormous mythical adversary. Now, every single animation for the Ancient was authored wholly in Engine by the Aaron Sims creative team using Control Rig and Sequencer, our linear cinematic animation tool. Also, just to push the boundaries a bit, they even built it out of a collection of NANITE meshes totaling over 50 million triangles attached directly to the skeleton. Control Rig was designed to keep artists close to their creations without having to bounce back and forth between software packages, allowing them to quickly iterate, all inside Unreal. While imagining the battle between Echo and the Ancient, we wanted to give the creature a heavy laser attack that Echo would have to avoid. We needed it to track Echo's location in the arena and fire a slow, sweeping blast towards her. Taking advantage of the full-body IK solver mentioned earlier, we were able to influence the direction and distance the Ancient reaches out during the firing animation, based on where Echo is in the scene. Let's see the results. Here is what the base firing animation looks like. And here it is again, with the full-body IK post-process layers enabled, and our info about Echo passed into Control Rig. With full-body IK and Control Rig,
yeah, so you can see it's kind of determining where it can actually place the bones. Obviously, they can't go infinitely far because his arm's not infinitely long, but essentially it's just solving, you know, for that particular point, what do all of the other joints along his arm and potentially his body look like?
Designers and artists can now author fully dynamic animations that react to gameplay without having to build complex animation state machines composed of numerous animation assets.
Yeah, I mean, that's good. You know, the more dynamic you have it, the better it's going to look anyway. You know, in a lot of cases, it is better to just try and author assets, you know, yourself, because certain things just, it's hard to get them to look good dynamically. But for a lot of other things, having them be dynamic so that they can respond to the world and respond to whatever the player is doing, respond to whatever the terrain is, you know, stuff like that, that's important. So don't get me wrong, I'm not saying like you know, moving into like a more dynamic state is better in general for pretty much every area of a game engine. Another really good example is AI. So the way that I see kind of dynamic AI is essentially what machine learning is, right? Instead of actually, you know, programming AI to do, if this, do that, or state machines or whatever, you're actually giving it the opportunity to learn, and thus it can actually adjust the behavior based on what that specific player might be doing, and that's really powerful. For animation, it's the same. For lighting, you know, being able to dynamically have scenes change because the player's shooting out some kind of, I don't know, some kind of like roof or ceiling in a cave that's going to allow light to go in, and then calculating the global illumination there, that kind of stuff, you know, that just means that the world feels way more alive and less static, because every kind of player experience is in fact going to be unique. Even though it might seem similar to like other players' experiences, you know, in this case, she ran to different points of the map than someone else would, and therefore that experience is different. And I think that's one of the coolest things that exists in video games, and why they are separate from like movies and other kind of, you know, static types of media, I guess. Because you define the experience, you as the player define the experience, and having a kind of dynamic world with all of this kind of dynamics technology, that stuff like really is the future, and it's really exciting to see stuff like this.
In Unreal Engine 5, we've completely overhauled the audio engine, centered around meta sounds, a new asset type used for every sound effect in our demo. Meta sounds bring the power and flexibility found in material editors to audio creation, providing fine control.
Yeah, that's good. That's good.
Game audio. With full audio synthesis capabilities and a rich audio function library, meta sounds give unprecedented control over sound effects and runtime applications. Using meta sounds, we built the Ancient's laser attack out of a combination of sound samples and synthesized audio. Let's briefly break down how it was set up. Using the stereo mixer, let's isolate and play just the synthesized charge sound. This effect is made by using a handful of sound wave generators and multiple modulation widgets. Now, let's mix back in our sound samples to hear the final result again. Alright, let's take down the Ancient.
Yeah, better audio tools are always good. I will say that that smoke effect just doesn't really seem like it suits the scene at all. I'm not even sure what it is, because it does seem like it's lit and everything. Maybe it's just the fact that it looks like just a video of like some smoke that's just been composited in. But that's probably like the worst looking thing in this shot, to be honest. Not that it's like particularly bad or anything, don't get me wrong, everything here looks amazing, but you know, I'm just saying. I feel like it's almost maybe the way that it's blending between the layers or something like that is weird.
Now, everything we've been showing you in today's demo focuses on some of the new features in UE5, but many of your favorite UE4 features, such as Niagara particles and visual effects, chaos physics, blueprint visual scripting, and more, have also received numerous updates in Unreal Engine 5.
Plus, all your UE4 projects can be upgraded to UE5, so you won't have to worry about forward compatibility for what you're working on now.
Here at Epic, we are passionate about building great tools and new technology. And a big part of our excitement is being able to bring you, the developer community, on the journey with us. So today, we're making an early access build of Unreal Engine 5 freely available on the Epic Games Launcher and the Unreal Engine GitHub, so you can explore and test out these tools yourself to get an early look at what's coming later in the full release of UE 5.0.
Also, we're releasing the project source for Valley of the Ancient, so you can check out how we use these features to build everything you've seen in today's demonstration. We've got a series of deep dive conversations
I might have to take a look at that.
Topics lined up for Inside Unreal,
good.
Our official weekly live stream, where you can hear from the engine dev team and ask more questions.
Yeah,
now,
that would be good to watch.
These are still the early days of UE5, and you can expect more news and features to be announced as we move closer to a production-ready release targeting early 2022.
Follow the
Still
Unreal
quite a while
Engine
away.
channels for more information, and feel free to download the early access release of Unreal Engine 5 and the Valley of the Ancient project today.
Thanks everyone for watching, and welcome to Early Access.
Okay, so I mean, my biggest thing at the moment is I want to see those deep dive kind of conversations. I really am interested in more of the technical details behind this. This stuff is cool. It's not any I don't know, it's not any different potentially than what we've seen like a year ago, so this was kind of, I guess, what I was expecting. I can't say I'm blown away with some other new feature. It is really cool seeing it kind of more usable, and the fact that this is clearly something that they're kind of moving towards a production ready environment, even if that does take another like half year or so. I'm not so much interested in the global illumination as much. I have some theories as to how they're doing that, and I don't think that's that groundbreaking, well, to me at least personally, but I am very excited about this NANITE stuff. Being able to handle that massive amount of data, and then kind of, I guess, determine what's on the screen and not having to worry about laws and stuff, I think that's really like the most powerful tool that is going to come out of this. So yeah, I can't wait to see more of the technical kind of information on that. In fact, I think the source code is like already available, so maybe I'll have a good read this evening. Anyway, thank you guys for watching. Don't forget to hit the like button if you did enjoy the video. Let me know what your thoughts were about all of this. If there's something that you want me to talk about or maybe take a look at, then also leave a comment below. Don't forget that I do have a bunch of various kind of game engines, C++ programming related content on this channel, so feel free to subscribe if you're not already and check some of that out, as well as follow the development of my game engine if that's something that you are interested in. Thank you guys for watching. I'll see you next time. Goodbye.